Hi, everyone. I'm Jiahua Wang from Broadcom. I'm going to talk about switch cable diagnostics with TDR using SAI and PAI. TDR stands for Time-Domain Reflectometer. A time-domain reflectometer is an electronic instrument used to determine the characteristics of electric wires by observing the reflect pulse. The TDR functionality of Ethernet PHY can be used to characterize or locate the faults in copper cables. When an Ethernet interface has a problem, performing a test, TDR test on the port can determine the operational cable status. The TDR functionality of Ethernet PHY can be used to determine the length of the copper cables. TDR sends a pulse into the cable under test, and at any impedance discontinuity within the cable, a reflection will be seen. Some impedance discontinuity examples are shown on the right side. There's cable short circuit fault, cable open circuit fault, and the cable joint. The reflected signal wave depends on the discontinuity type. So from the reflection signal, we can determine the cable faults or cable lengths. The signal on different, the copper cable usually have many pair of wires. The signal on different line can detect crosstalk. And we also give some examples of device supporting TDR. I believe many vendors supports the TDR function on the PHY, but we only implement on the following 4 devices with SAI, PAI, and Sonic. So the first one is a built-in PHY. So for on the switch ASIC, so the switch SDK supports both switch and the built-in PHY. And we have a legacy copper PHY, which is a standalone PHY, but it's for the legacy reason, the switch SDK supports the PHY. And we have modern copper PHY, which is also a standalone PHY, and the newer PHY drive and the EPDM software supports the modern PHY. Then we also have the COP SFP, which is not supported by either PAI or SAI, or its TDR functionality is accessed by the SFP extended I2C registers. Switch Abstraction Interface is a standard API for multiple ASIC vendors to provide a consistent interface to program their device, which includes both switch and the PHY. The standardized API for PHY is also called PAI. The TDR function is implemented using SAI and the PAI. For examples I showed you in the previous slides, the SAI supports the TDR for the built-in PHY and the legacy PHY, and the PAI supports the TDR on the modern PHY. We have proposed 3 new side port attributes for the TDR cable diagnostic. And they are cable pair state, cable pair length, and the cable types. For the first 2 is read-only, which means we can read the attributes to get the, to initiate the test and get the result back. The last one is create and set, which means we need to set it before we start the test. each of the attribute has a different value type. The pair length, obviously, is some kind of integer. The unit is in the meter. The reason is, although the register has a resolution of centimeter, in reality, we only can guarantee within plus minus 10 meters accuracy. So the unit of the meter is appropriate. And for the other two, I will show you the type, which is enum type, on next slide, on this slide. So the state will be OK, open, short, crosstalk, and unknown, which I will explain one more times on the next few slides when I show you the sonic command line output. And the cable type is well known, the Cat5, etc. So although the SAI and PAI can be used in many different NOS, and Sonic as a leading, the choice for the data center and enterprise, and also, to our knowledge, to my knowledge, Sonic is the only NOS has supported both SAI and PAI. Some other NOS although use SAI, but does not necessarily use PAI. So if you are familiar with the Sonic, you can see all the different process. So the flow goes like this. We have Sonic CLI to initiate the TDR. Which goes like this. The Sonic CLI will write to the AppDB. We're using the interface table. And transceiver daemon will read the AppDB based on the port type. You will change the interface table entry, which Awk agent can read later. Also, as I mentioned earlier, we support the COP SFP, which is accessed by the I2C. So if it's COP SFP, then the transceiver daemon can process there. It doesn't have to send to the Awk agent. Also, it's a different topic from what I'm talking about. There's also what's called optical TDR, and probably the transceiver daemon probably will be the right place to process the command. Then the Awk agent will read the AppDB. Based on it's a gearbox port or not, you will send to the syncd side, SAI, or GB syncd PAI. So the GB gearbox port means it's the port has a file which is supported by PAI, not by SAI. It's a two different process, it's a two different dock. So so the command will go through either ASIC DB or GB ASIC DB, and processed by syncd or GB syncd using SAI or PAI. The results will come back to the Awk agent, and the Awk agent will post the, will update both AppDB, so we know the command is finished successfully or not, and also it will update the state DB. We would get the TDR result. Then there's a separate Sonic CLI to get the TDR result back. So the Sonic CLI syntax is as following. To initiate TDR cable diagnostic test, we have the command test cable diagnostics. Also, we can give the Ethernet port number or port range. To collect the TDR test result, we can, using the command show cable diagnostic port, or we only want to know the cable length, we can do a show cable diagnostic cable length. Both commands can give the port number or port range. This is the command line output. So one thing you must notice that when we initiate the TDR cable test, it's a disruptive. So it will give you a warning, say, do you want to continue? Then we have the result here, and most are okay, the cable okay. And then we have one cable is open, one cable is short. I mean, the short circuit or open circuit. So this is the detailed explanation of those status. And okay means it's okay. Open means it's open circuit, and most likely you don't have the cable plugged in. And the short and the crosstalk probably means it's a bad cable. And unknown, there could be some other reason. Actually, one thing I can think of is that we define the short and open for the entire cable. We have many pair of lines, and if you get an inconsistent result, then it will give you unknown. And if for some reason, the driver, the PAI, or the SDK couldn't perform the test, and then we get the failure. By the way, the OK is, which means on the, the 4 pair of Ys, every pair is OK. Every pair, yeah. So in summary, Sonic as a network OS now has the switch cable diagnostic function with TDR using SAI and PAI. The TDR test operation may cause temporary disruption of traffic. The TDR test result may show cable faults or cable lengths. The TDR is a very useful tool to debug the link issue due to physical cable issues, which is one of the significant challenges in massive data centers or big enterprises. Call to action. Broadcom has contributed the TDR cable diagnostic SAI pull request. It's listed here. The new TDR SAI API could be used in the SAI by any switch vendor to support built-in PHY. The new TDR SAI could be used in the PAI by any PHY vendor to support the standalone PHYs. The new TDR SAI API will be used by Broadcom Sonic, and Broadcom will continuously actively contribute to the OCP and the Sonic community. Thank you.
Thank you. I don't see any question. Yeah, there's a question.
Quick question first. What's the difference between short and crossed?
Oh, short means you have just one line, one pair of Y. It's short, so basically the line itself is short circuit. And the crosstalk is you have 2 different pair. And the other, they should be isolated from each other, but somehow the signal get crossed from one pair of Y to the other pair of Y.
They are not short.
They are not short.
But
yeah.
They have
signal crossing. Yes. Okay,
cool. So what is TDR difference between TDR and PRBS?
PRBS usually it's it's a pseudo random things. You send some kind of pseudo random signal, but actually it's a pseudo random. You wouldn't know the result, right? So when you send over, you know whether the one received is it's the same as what you send. And the TDR is basically just using the reflection of the signal to determine, for example, I mean, the only TDR can determine the cable length because, because the physics, the X signal travel at a certain speed for different type of cable, right?
I understand that TDR doesn't require the peer side to anything.
No, it doesn't. It doesn't. So basically, if you have the cable plugged into one switch, the other end is not plugged in, then you will basically it will just tell you that it's an open circuit. I believe even when you plug in, even the other side is not powered on, you will still know the cable length because when you plug it in, when the cable goes in, the first thing is a small transformer, a magnet. It's an isolated transformer, so which doesn't require power, right? So you will know the length of the cable as long as you plug it in.
I see. Yeah. No, thank you very much.
Thanks everyone again.
Thank you.